I see you're still here. Well, let's talk about the hard light theory. The hard light theory essentially came from E equals mc squared, but with c, the speed of light, equaling 1 unit of the speed of light. And yes, I know it would be a vector. Well, the absolute value of a vector, but it can still fit into one slot in an array. And so therefore, 1, it is E equals m1, because 1 squared is still 1. And in that case, energy equals mass times 1. Energy equals mass. Mass is energy. That's essentially the whole theory. But to explain it, how it would work is if your body were to detonate, every atom split, it would be roughly, it'd be bad, but yeah, um your body has enough atoms in it that if they split, then goodbye whatever state you're in. But back to the hard light. It's based off of Einstein's work, but it's more relative now, because essentially the way I see it is, if energy is mass, then that makes sense why it absorbs itself into a sphere every time. The Earth is a sphere, the Sun is a sphere, galaxies are round, gravity makes spheres, which essentially tells me electrons are orbiting atoms because of gravity. And why are they round? Gravity. Now, this is an unexplained theory that gravity, you have to pardon my speech, is I have a mental disorder that keeps me from focusing completely sometimes. But anyway, yeah, panda syndrome. But look it up. It's fun. No. But no, it's not fun. But where did my light go? Oh well. Well, anyway, so you take gravity and you scale it. It is scalable, but think about it. When an ant falls off a building, it doesn't die. So it's scalable, but it doesn't have the kinetic energy from it is not scalable. Like one atom, if you were to split it, you would not even notice it. You wouldn't even see it. In a completely pitch black room, if one atom of any type split, as long as no more atoms are split because of that atom splitting, you could have it in the palm of your hand and you wouldn't see it, you wouldn't smell it, you wouldn't feel it, you wouldn't hear it, or you certainly wouldn't taste it. And you wouldn't be affected by it at all. There are over essentially 4 times 1 million times 1 million times 1 million times 1 million atoms split into 2 pounds that actually underwent fission in Hiroshima and Nagasaki. Now, I don't think one atom is very, if that, well, essentially scale that down divide it by 1,000,000 4 times, and then also by 4. And there you have it. That's what it looks like when an atom blows up on your hand. Nothing. But for its size, it is extremely energy dense. And I say that's because it is energy. Mass equals energy. You know? Energy groups together. Now, what energy is a different story. But I can tell you, based off of the hard light theory, that it is energy held together by gravity, or at least what we call gravity. Every atom held together, the energy that makes up the spheres that make up the electrons, the neutrons, the protons, held together by the same force that holds the moon towards the earth, that holds the earth together, really is what I should have said, and the same force that pulls the moon around the earth, pulls the electrons around. By the way, those electrons are going extremely fast. Their tangential speed is incredible, but their actual speed in any one direction, if they were to, their speed is incredibly slow. They, think about it, of how small they are. They're changing direction so extremely fast. Because, in a circle or orbit, you're 100% of the time changing direction constantly. Therefore, it doesn't have a solid direction ever that it's going until the donut plane theory for orbit, which I'll get into next with the tripendicular orbit.